Right, we've cracked the 40 centigrade. It's now up to 41 and still climbing. That is hot. It's almost uncomfortable to hold, and that is just with a small section of copper pipe over the exhaust. As I say, 3 lengths of this you could get in the full 1 metre exhaust length. You wouldn't have no issues at all. And it's all free, gentlemen, it's free.
This is the method how you go about doing this. Simple 12 volt pump, pick a low amperage type, 3 metres of 6mm copper piping. Any steel former you can fit inside the exhaust pipe. As you can see, a tight fit inside the exhaust pipe. Clamp the steel pipe firmly into a vise. Firmly wind the copper pipe around the steel former. You must pull it tight against the steel former. Pulling hard enough will cause the copper pipe to slightly flatten. Continue to wind it for as long as you can. 3 metres of copper pipe doesn't go far, as you can see. It actually makes a length of 230mm. If you don't pull the pipe tightly, then you end up with it kinking, and you don't want that. As you can see, it happened right at the beginning of my turns. To remove the copper from the steel bar, you use the ends and wind them in the opposite directions, thus opening the spring. The same method is used in reverse to get the piping back onto the stainless steel exhaust. The method works very well and gives you a very tight fit of the copper against the stainless steel exhaust tube. Now for the final lash up to see if it all works. Closed loop and water in a bucket provides all we need. Notice there's no insulation anywhere here. It would greatly help efficiency and also, of course, heat retention from the exhaust to the copper tubing. The heater has been started and the timer is set. Here we go. We start off with a bucket water temperature of 11.6 C. The unit heats up after 10 minutes. This is totally inefficient. The actual system isn't insulated to hold the heat in. It's just a bare bones system. But with a 3 metre length of copper pipe wound around the exhaust pipe, there's room for it. How brilliant this would be. You would get rapid heat transfer, and you could use the water somewhere else to heat a hot water tank or just to stop your main tank from freezing. Got to be worth a try, gentlemen. It's free. Have a go.
Right, a couple of interesting points to note on this. Number one, the efficiency would be a lot greater if this was actually insulated. Bearing in mind the size of this, that's 10 foot of pipe in there, so with a metre you could have about 30 foot of coiled pipe in there. Plus, if you insulated that with the exhaust wrap, that would help keep the heat in. That would also increase the efficiency of the system. I don't know if you can actually see, but there is actually a bit of steam coming off of this now. I can't believe it, it's amazing. So with 10 foot of copper coil tight wound around the exhaust, I'm actually getting steam off of this water now. It's absolutely amazing. I can't believe how good it's been in such a short period of time. So we'll see how it goes and see what we can get this up to. But with a small coil like this, the efficiency with 30 foot of coiled copper instead of 10 foot of coiled copper, and also if it was insulated over here with the insulation wrap, would be a lot better. I just can't believe it. It's working much better than I thought. Now you could extend this copper pipe and you could take it into a hot water pipe, and this type of thing that you've got here, you could actually use a tank, use the pump, circulate it through the exhaust, return it to the tank, and that could be your hot water if you wished to do this. Your choice. The pump itself uses hardly anything. It's a diaphragm type pump, I believe. It's not a motor pump, doesn't use much at all, and just a little gentle tick in there, but it's amazing. It just needs a little bit of water. As you can see, it's not a tremendous amount of flow there, which just takes enough heat through the or enough water through to absorb the heat. And you can see, I think, the steam rising there. I'm hoping you can anyway. I can see it visually, but I don't know if you can actually see it with the camera, which is rather a shame. But I can assure you this water is hot enough to get steam come off it when the wind dies down a bit. It's quite stunning, absolutely amazing. So I've got a third of the pipe that you could have on here, no insulation on it whatsoever, and I'm going to do a test in a moment to see what temperature we've actually got this up to. Juggling about a bit, but nearly up to 40°C. Not bad going, is it?
Here we are at the final part of the test. I'm going to shut down shortly. The unit's been on for an hour, as you can see, and I'm now shutting down and the experiment reaches completion.
One last time. I've turned it off now, so it's going to be cooling down, but I'm hoping that you can see the steam. You can definitely see it, but that is hot. So that's after an hour from start up. That's not bad at all. There you go, see the steam. There we go. It's hot. Right, I'm going to call my experiment quits now. I think I've proved the point, and I'll leave it to others to actually have a go and see what they can produce. But it's a working system, gentlemen. Free heat. Either throw it out the atmosphere or use it in your RVs and use it. It is not hard to do. All the best.
Just a quick word for those of you that might have seen the first video that I did of this, which was started because I had a bee in my bonnet about all that heat going out of the exhaust. I bought a radiator and bought all the gear to do that experiment, and because of all the questions that I had and that it raised, I decided to spend some money out and buy the copper pipe and bits and pieces that you can see here for this experiment. So I hope that it will be useful to somebody out there, which I'm sure it will. Anyway, if you could subscribe, that would greatly help. Thanks for watching. All the best. See you next time.